Hello. In this video, we're going to prove the quotient rule. So the quotient rule states that the derivative of f of x over g of x is equal to g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. To start this proof, we're going to need to remember the definition of the derivative. So stated here, it's the limit as h goes to 0 of f of x plus h minus f of x all over h. So we want to apply this definition to this function here, which is composed of both f of x and g of x. So the first step, that would be natural, is to ask ourselves, what is f of x plus h minus f of x? Or in our context, we have f of x plus h over g of x plus h minus f of x over g of x. Now this is not particularly useful in the current form because they're two separate pieces, and we would like to combine this into one single piece. So what we should do is find a common denominator between the two of them. Here we're missing a g of x, and here we're missing a g of x plus h. So if we multiply and divide by g of x, and over here by g of x plus h, we will obtain a common denominator. So this will give us f of x plus h g of x minus f of x g of x plus h all over g of x plus h g of x. So now that we have our function in one piece, we can go ahead and divide by h and set the limit as h goes to 0. So that will look as follows. The limit is h goes to 0 of f of x plus h g of x minus f of x g of x plus h all over h g of x plus h g of x. This still doesn't look like any limits we know. The problem we have here is that in our original assumptions, of course we're assuming that f of x is differentiable, we're assuming that g of x is differentiable, and we're assuming that g of x, and particularly here, is not equal to 0. So we have to ask ourselves, how can we use the fact that we know f of x is differentiable, we know g of x is differentiable, how can we use that in the limit we have here? Now the trick is going to be to add and subtract f of x g of x from the numerator. Now I'll show you on the next line why this is so useful, but you should be able to start to see it if we look at the two outside terms. Here we have f of x plus h g of x, and here we have f of x g of x subtracted. Looking at these two terms here, if we were to factor out this g of x and factor out this g of x, just looking at those two terms, we would have f of x plus h minus f of x. And that would start to look like the derivative of f of x. Similarly here, we have g of x plus h and g of x, both with a common term of f of x. If we were to find a way to factor that out, we would also have g of x plus h minus g of x, which would start to look like the derivative of g. So let's do that on the next slide. So here we have our original limit, and we see that there's a g of x and a g of x in common with both of those terms, so we factored out g of x, and we're left with f of x plus h minus f of x. Similarly, for both of these terms, we can see there's an f of x in common, and so we factor out a negative f of x, which gives us g of x plus h positive minus g of x. All of this is still over h, g of x plus h, g of x. Now what we're going to do is use the rule of fractions that says if we have two numbers on the top that are being subtracted, we could rewrite this fraction as two separate fractions, this one and this one, still over the same denominator. So let's go ahead and do that. So now that we've split up our fraction, let's take a look here. We have f of x plus h minus f of x all over h. And we have g of x plus h minus g of x all over h. Both of these are the derivative of f and g respectively. And in the proof we are assuming that f and g are both differentiable. So what this says to us is that we can take this entire portion here and rewrite it as f prime x. Similarly, we can take this entire portion here and rewrite it as g prime x. Now, of course, g of x plus h, as h goes to 0, will go to g of x. So this will go to g of x times g of x. This will go to g of x times g of x. And we can put the fractions back together. So what we will have is g of x, f prime x, minus f of x, g prime x, all over g of x squared. And that proves the quotient rule. Again, a fundamental ingredient in this proof is the fact that we could add and subtract f of x, g of x, as well as splitting up the fraction into two parts so we could recognize both of the derivatives that we had. This completes the proof. Thanks for watching.